Here is a magic trick performed by arithmetic. I send you 7 bits, ones and zeros. While they travel, you may sabotage them. Flip any single bit you like. Any one. Don't tell me which. When the message arrives, I do a little math and the message itself announces, bit 5 has been flipped. Not something is wrong, the exact location. Flip bit 2 instead. It says 2. The message carries no copy of itself, no list of suspects, no spare parts, just 7 bits, arranged with malice aforethought. This is the Hamming code, and by the end you will be able to perform the trick yourself, on paper. First, why the trick matters. Every channel is noisy. A scratch crosses a disc. Static hits a radio link. A cosmic ray, a real particle from a dead star, strikes a memory chip and flips one stored bit. And digital information is brittle. Flip 1 bit of a number and a payment changes by thousands. Flip 1 bit of an instruction and a program dies. The 1940s answer was retransmission. Detect trouble, send it all again. But what if there is no again? A probe past Jupiter, a disk already sold, a memory chip mid-calculation. The message has to survive on its own. The obvious armor, say everything 3 times. Send each bit as a triplet. 1 becomes 111, and let the receiver take a majority vote. 1 flip in a triplet. Outvoted, corrected. It works, and it is ruinously expensive. 2/3 of the channel now carries repetition. With a 1% noise rate, voting drives the error down to 3 in 10,000. But your 7-bit message now costs 21 bits to send. Repetition buys safety with brute force. Hamming wanted the safety without the bill. The cheap tool, a parity bit. Append 1 extra bit, chosen so the whole message has an even number of ones. A single flip anywhere breaks the evenness. An alarm rings. 1 bit of cost, perfect detection. But the alarm has no address. Something is wrong somewhere. To fix the error, you'd still need a resend. Detection without location is a smoke detector with no rooms. It tells you the house is burning, not where the fire is. Hamming's question, can several alarms cleverly overlapped triangulate the flame? Draw 3 circles that overlap like a pretzel, 7 regions in all. Place your 4 data bits in the 4 overlap regions, and in each circle's private region, write a parity bit that makes that circle's total come out even. 3 circles, 3 tailored alarms. Encode the data 1011. The parities work out so the full message reads 0110011. 7 bits, of which 3 are guardians, each data bit watched by a different committee of circles. That overlap is the entire secret. Now the sabotage. Flip bit 5. Check circle A, odd alarm. Circle B, still even quiet. Circle C, odd alarm. 2 alarms and 1 silence, and geometry does the rest. The culprit must live inside A, inside C, and outside B. Exactly 1 region fits that description, the home of bit 5. Flip it back, every circle calms. Try any other bit. Its own unique pattern of alarms betrays it every time. 112 possible single errors, all 112 caught and corrected. Hamming's arrangement hides one more jewel. Number the positions 1 through 7 and place the parity bits at positions 1, 2, and 4, the powers of 2. Now read the 3 alarms as digits. C, B, A, a 3-bit binary number. Flip bit 5. Alarms read 101. 101 in binary is 5. The code does not merely locate the error. It pronounces its address in binary, no lookup table required. The alarms don't point at the wound. They spell it. Why does it work? Geometry. 7 bits have 128 possible values, corners of a 7-dimensional cube. Of those, only 16 are legal code words, and any 2 of them differ in at least 3 positions. Around each code word, draw a ball. The code word plus its 7 one-flip neighbors, 8 corners per ball. 16 balls, 8 corners each, 128. The space is filled exactly, with no gaps and no overlaps. Every possible received message lies within 1 flip of exactly 1 code word. Hamming's code isn't clever patchwork. It is a perfect sphere packing in 7 dimensions. The inventor was simply fed up. Bell Labs, 1947. Richard Hamming has weekend access to a relay computer, but no operators. He queues his problems on punch cards, drives home, and too many Mondays he returns to find the machine had hit 1 error, thrown everything out, and sat idle for 2 days. If it can detect the error, he fumed, why can't it find it and fix it? 3 years of thought became the 1950 paper. And it landed beside a giant. Claude Shannon, same halls, had just proved that reliable communication over noisy channels is possible in principle. Shannon promised it. Hamming built the first one. Honesty requires the fine print. Flip 2 bits, and the alarms still ring, but they triangulate the wrong cell. The code confidently repairs a bit that was never broken. 1 flip healed. 2 flips fooled. The standard patch is an 8th bit, a parity over the whole word. 2 errors then break the alarms in a recognizably impossible way. The code says, damaged beyond repair, resend, instead of guessing wrong. Correct 1, detect 2. Never a free lunch, only precisely priced insurance and stronger codes for harsher channels. Now look at where the trick lives today. Server memory ships with extra chips running exactly this scheme. Cosmic ray bit flips are routine at scale, and ECC memory heals them mid-computation. Space probes wrap their whispers home in descendants of Hamming's idea, built for channels where a resend takes hours at light speed. The QR code with a torn corner still scans because Reed-Solomon codes. Hamming's heirs treat the tier as just another flipped symbol. Disks, SSDs, Wi-Fi, television, every one of them is quietly, constantly finding fires and naming rooms. The world runs on messages that heal. 3 overlapping circles. Parity bits on the powers of 2. Alarms that spell the wound's address in binary. A packing of spheres so perfect that 7 dimensions leave no room for doubt. Hamming's code was the first proof by construction that information does not have to be fragile, that a message can be shaped to know when it is heard and where. Every reliable machine you own is built on that shape. A message that knows its own shape can heal.